All right, guys. More rational functions. Same stuff. We're just going to go through that process and add a couple of things in to this. So more rational functions. The first thing that we always find before we do anything else is what? Domain. And what do we do to find the domain? Okay, I liked what I heard. I heard factor and set what equal to 0? The denominator. All right. After we've discovered what the domain is, what's the next thing that we should do? Simplify. That's the next thing. And, right here where we said factor, we should factor the denominator for sure to get the domain. But we also need to think about factoring the numerator as well so that we can simplify if it will. The key here today is a lot of them do simplify in this particular section. Okay, so simplify. So factors, cancel. All right. And then after we simplify it, that's when we find what? Asymptotes. Vertical, horizontal, or oblique. Find those, okay? All right. One of the things we're going to add here today that we didn't do with the equations in 5.4, we did it with the graphs that they drew in 5.4. We didn't do this with the equations, is find the intercepts. Okay. How do you find an x-intercept? Yeah, y equals 0, solve. Find a y-intercept, x equals 0, and solve. We got our vertical, horizontal, oblique asymptotes. Holes are, that's one of the things we're adding. Okay, so we're intercepts and holes, and if the graph crosses the asymptote, that's the thing. That's the two things we're adding today. Okay, holes occur from the simplifying. Okay, we're going to see that as if we simplify a factor. Remember, it was also part of the domain. So, like if we had a problem where we'll just make this example A, and we'll start our process. So f of x is equal to, maybe I'm going to go ahead and do x squared minus 4. And then I'm going to go ahead and have the bottom part factored as x minus 2 and x plus 7. Okay. So domain is what we would find first. And I think through this example, we'll see what holes means, and then we'll go from there, okay? So the domain, how do we get that? Yeah, set x minus 2 equal to 0, x plus 7 equal to 0. And we get x can't be what? 2 or negative 7. Remember, you got to change the signs on those. So that's okay. We can do interval notation if we want to. We'll stop there. There's a lot of other stuff. We got a lot of other fish to fry in this. Okay. So the next thing to do would be simplify it. So we need to look at that numerator and say, okay, can it factor? Yeah, it's x plus 2, x minus 2, because it's a difference of squares. So yeah, because the x minus 2's are going to cancel out. That's going to give us a vertical asymptote at x equals -7. It also gives us a hole at x equals 2. So when you cancel out a factor, what it creates is this hole in the graph, because 2 is a restriction on the domain. So that x value can't be used. When we look at the graph, it actually does exist on the graph, as far as the line looks like it goes with an x equals 2 value, you get an ordered pair. But actually what's happening there is you have a hole at 2. So we need to find the actual ordered pair that hole exists at. So we need to find f of 2 and work that out. So I could use the original form. I could use the simplified form. I'm going to use the simplified form because it's easier. 2 plus 2 over 2 plus 7, 4 over 9. So there's a hole at x equals 2, which turns into the ordered pair 2, 4 over 9. We'll look at the graph in just a minute, and I'll show you kind of where I'm getting. So I'm taking the factor that canceled out, whatever x equaled on it for the domain, that I'm plugging that in to the simplified version of the problem. Okay, so I'm putting a 2 in the place of x, so x plus 2 and x plus 7 is all that's left. So 2 plus 2 is 4, 2 plus 7 is 4 over 9. So it creates this ordered pair. What's going to happen is if we were to draw this graph, there's going to be an empty circle. Remember those for piecewise defined functions? We use those a lot in that. There's an empty circle at that spot on the graph. So we'll look at the graph of it in just a minute and get all of it together.
If the vertical asymptote is 2, then it would be a hole at -7.
It's all on what factor canceled out. The factor that cancels out is the one that creates the hole. Yes, it's always whatever it was. X would equal if you set it equals 0, and it's coming from whatever's in the domain that's not a vertical asymptote. Okay. All right. So let's look at what's next. Horizontals or obliques? Where? What's the degree of the top? Well, it's 1 here and 1, so it's the same. So they're equal to each other. So the horizontal asymptote would be at the ratio of the leading coefficients would be 1. Okay. Now we need to find out. We know it's got a horizontal asymptote. What do we know about oblique asymptotes? Ain't any. None. Okay. Now we also need to. One of the new things is find out if it crosses that horizontal asymptote. Because it can cross a horizontal asymptote. It doesn't cross vertical asymptotes, technically, or obliques. But horizontal asymptotes could possibly cross. So we want to see if the equation crosses that. So we're going to set f of x. Okay, so we're answering this question right here. Does f of x cross the horizontal asymptote? So we're setting x plus 2 over x plus 7 equal to 1. Because that's what the horizontal asymptote is. It's y equals 1. This is f of x, this is y equal to 1. And solving that. If we get a solution, then it crosses it. If we don't get a solution, then it doesn't. So how do we solve that anyway? Yeah. Cancels. And then subtract 2. Subtract x. And what happens to x minus x? 0 equal 5. That's no solution. So the answer to that is no. It does not cross the horizontal asymptote.
So
You set, go ahead,
you take the simplified version.
and set it equal to whatever the horizontal asymptote.
So if it has
It won't cross a vertical. It could cross an oblique, but it doesn't happen very often. But either way, you just set the simplified version equal to whatever your horizontal or oblique asymptotes are. Okay? Thomas. What do you think? Not necessarily. It could be. It's like a fraction multiplying out. Right, which would mean it would cross. But if it's y equals 5, it would, if it's 1, it could still cross it. If it's 0, it could still cross it. So you got to work it out to see.
Where will it mess you up? Because
There's tons of places.
all you did was put basically x plus 2 equal to x plus 7. But I feel like
But I did that because I cross multiplied here.
Yeah, I feel like if that was a 2, then that would mess you up doing something.
It's not going to mess you up if you do it correctly. So you multiply here. To get x plus 2 equal to x plus 7, I distributed 1 to both of those. So if that's a 2, you distribute 2.
Yeah.
It is too easy. It's algebra. Last thing, intercepts. Last thing for this thing is intercepts. We did all the hard work we did in 5.4, and then we do intercepts. Okay, so to get the x-intercepts, we're going to set x plus 2 over x plus 7 equals 0. Get x plus 2 equals 0. X equals -2. Okay? You got to keep in mind what our domain stuff is. That's similar to one of the things that's a restriction on the domain, but it's not. Okay? So, got an x-intercept at -2, 0. How do we find a y-intercept? Yeah, so we find f of 0. 0 plus 2 over 0 plus 7. Same way I solved for that. If I multiply by x plus 7, what's 0 times x plus 7? 0. So that's why it's all that's left is x plus 2 is equal to 0. Okay. That's what's going to happen every time. Is your numerator is all you end up setting equal to 0. Because the denominator is always going to cancel out when you multiply. So it's really just the numerator equal to 0. Okay. All right. There's our intercepts. Now I said we'd look at the graph. Let's look at the graph of that and see where about that hole and what that looks like, and what we can tell that's going on from there. So we had x squared. Well, yeah, let's do x squared minus 4 over, and then I'm going to do the two factors there, x minus 2. So I'm graphing the unsimplified form because that was the original problem. Okay, and was it x plus 7? Graphing the original problem, not the simplified version.
Go back to
Make sure you put double parentheses around the denominator, or multiply that out and get x squared plus 5x minus 14.
what is the double sign?
It means that all of that's inside the outside parentheses is in the denominator. So they got numerator in parentheses, denominator all in parentheses.
Is that whole? That for it not together?
What do you mean? No, the whole if you look at the graph, we got a vertical asymptote should be at what? X equals -7, right? There's that. That's where it's not together. Okay, we got a horizontal asymptote at y equals 1, right? And then we know it doesn't cross that because we found that algebraically. We got a x-intercept at -2. That's right there. Okay. Y-intercept at, what was it, 2/7? That looks like probably right. Okay. The hole we found was at what? X equals +2. If I hit trace and type in the number 2, notice what it gives me for y. Nothing. That's the hole. Notice you cannot see that on there. That's how you check it to make sure that you found the right number. You found the right place.
So wait, is it the 4/9
The 4/9, because that's where, if you were to draw this graph, you would need to put a hole at 2 4/9. And then the empty circle would be where I have to draw this graph or match it up with. 4/9 is the Y value.
Honestly, why didn't it show it on the graph?
Well, it is by doing that. It's just not going to draw an empty circle there for you.
So why do we even have the whole new place to do anything?
They do something. They create a spot in the graph that's empty,
Yeah, we can't see.
but you know it's there. I mean, if you can't see the spin on the ball, what's the point in somebody telling you a curveball's coming? Doesn't do you any good, does it?
It's big, big way in it.
But true, so it doesn't matter if somebody tells you. But if you tell you it's coming, at least you know not to be looking for a fastball, right?
Why did you do -2?
Because -2 is not where the hole is. The hole is at +2. That was the factor that canceled out. Let's look at another one.
I have a question. How did you get the further intercept? I got how you got the -2 if you did the bottom.
To get the y-intercept, I plug a 0 in for x. That's how I get to it. All right, Pebble Beach. Let's do this. Let's do 6x plus 9. Let's do 6x squared plus 9x over 3x minus 2. There you go. That's even better. I like that better. Okay, so the first thing we're going to do is what? Factor and domain. Okay, so I'm going to factor the top. Go ahead because I know it will. It's 3x. 2x plus 3. And the bottom part's 3x minus 2. Very similar stuff, but not the same. What's my domain? X does not equal 2/3. Am I going to have any holes in this graph? Why not? Nothing canceled, so there's not a hole. Okay? That's important to recognize the difference. Nothing canceled, so there's no hole in this graph. Okay? Vertical asymptote then. Vertical asymptote's the same thing we did the last 3 days. Same as domain because nothing canceled. No holes because nothing canceled. Same reason that the vertical asymptote's the same as the domain. Because nothing canceled. So there are no holes in this graph. Okay. Horizontal asymptote. None. Why not? Why is it oblique? Numerator's one more than the denominator. Agree. The numerator is one more. So there's no horizontals. Oblique means long division. There you go. So we're taking 3x minus 2 and dividing it into, I'm just going to go to 6x squared plus 9x. And I'll go ahead and put a 0 there on that end. 3x times what gets me 6x squared? 2x. Careful with your subtraction here. 9 minus negative 4x. Be 13x. And so we got to think here. What times 3 is going to give me 13? Give me a better answer than that.
4 1/3.
Give me an even better answer than that. 13 over 3. What times 3 gives me 13? So you could set it up 3 times A equals 13. That's how you find that number. And it's okay, it's a fraction. That ain't a big deal. Do we need to even go any further?
No.
Why?
It's MX plus B.
Yeah, it's mx plus b. That's the right form. So that's my oblique asymptote. Okay. Now, see if it crosses it. Does so we're going to set the problem. I'm just going to go back to the original. Since nothing's simplified, I'm just going to go back to that because I'll end up having to do that anyway. Over, what was it, 3x minus 2 equal to 2x plus 13 over 3. So I'm setting the function equal to the asymptote. So oblique this time. Okay. That's finding that number. That's how I found that number. What times 3 gets me 13? So I said 3 times what equals 13, and then solve it. That's how you can, if it's not an easy integer, that's how you can get that answer. All right, now, what do we do next? Yeah. I'm multiplying that old side by that. So the left side, I'll do that one. That's the easy part. The right side, polynomial method, distributed property, whichever way you want to call that. 2x times 3x is
6x squared.
That's a good thing. 2x times negative 2 is negative 4x. 13 over 3 times 3 plus 13x. And then minus 26 over 3. And I'm going to simplify. 6x squared plus 9x minus 26 over 3. And then what's going to cancel out here? Yeah, the minus 6x squared, those cancel each other out. And if I move the 9x, yeah, it cancels out too.
Teachers, can I have your attention for a moment,
So,
please? This time we will be participating in the statewide tornado drill. Would you please exit to your appropriate post as of right now? Thank you.
all right, guys, we're out here in the hall. Go quickly so you get the. All right, so we were there. We were solving this. Turned out all the x's canceled out. 0 does not equal negative 26 over 3. So the answer to that, does it cross? No. That's the verification that it does or does not. Okay, you set them equal and solve. If you get x equals a number, then yes, it does cross it. So the answer to that would be yes.
So 0 equals 13 over 3, then it's dead.
What was it? If you get x, if you've still got an x in the problem and it's x equals a number, then it does cross. If you don't have x's left, then it doesn't. That's
What if it's 0, like, what if it's equal to 0 and like 0 equals
then it would cross it every moment of every point, and that's not going to happen. That is basically the answer to that. All right, let's look at this one. We're on C here. Intercepts. I forgot those. Nope. I'd have to kill you first, and that's not going to happen.
I like it cold.
I'd rather have it cold than hot. All right, so intercepts. All right, so intercepts, original problem. Set it equal to 0, 6x squared plus 9x over 3x minus 2 equal to 0. So it ends up you got 6x squared plus 9x equal to 0. Factor that, it's 3x, 2x plus 3. 3x equals 0, 2x plus 3 equals 0. So we have x-intercept at 0 and negative 3 over 2. Y-intercept the f of 0. And that should be 0. Because 0 divided by anything is 0. And get a 0 in the numerator, that's what's going to happen. So those are our intercepts. They're at 0, 0, and negative 3 over 2, 0. Technically, that's x and y intercept, and that's an x intercept. Good? All right, 3x squared minus 9x over x squared plus x minus 12. That's our next problem. So what do? Factor. So I'm going to go ahead and factor top and bottom. So 3x, x minus 3. Bottom part, how does it factor? Yeah, x plus 4, x minus 3. Well, multiplies to be negative 12, adds to be positive 1. That's what does that. Now, before we simplify, let's do the domain. X does not equal what? Negative 4, positive 3. Okay. Simplify. Vertical asymptote. X equals what? Negative 4. There's a hole where? X equals 3. So we need to find the y value that goes with that. F of 3. 3 times 3 over 3 plus 4. So I'm using the simplified version to do that. It's less work. 9 over 7. So 3, 9 over 7. So this is the x value where there's a hole. This is the ordered pair where that hole shows up in the graph. Okay. Horizontal asymptote or oblique. Why?
Degrees are the same.
Degrees are the same. What's the horizontal asymptote then? Y equals 3. If the degrees are the same, it's the ratio of the leading coefficients. So 3 over 1. Okay. That 3 over 1 or this 3 over 1, it should be the same.
I like that.
Okay. Does it cross it? How do we tell if it crosses it? Don't plug in 3. Set what equal to the horizontal asymptote? Yeah, the simplified version. The last one didn't simplify, so we just set the original equal to it. So here we're using the simplified version, setting it equal to that. So that'd be 3x equals 3x plus 12. And does it cross it? No. And last thing, intercepts. We're much better at this than we were yesterday. We're much better than this than we were at the beginning of the class today. All right, so intercepts, 3x over x plus 3. X plus 4. That's what it should be on the bottom. Equal to 0 to find the x-intercepts. 3x equals 0, 0. So it's 0, 0. And then to find the y-intercept, should end up with 0, 0 being the only intercept we have. Because f of 0 is 0, just like when you solve this, you got x equals 0. So there's only one intercept for this one. It's at 0, 0.
On the bottom, that's 0.
Right here. That says 0 plus 4. All right, guys. 382, 7 through 38. A work day tomorrow over this stuff. This does take practice to get different scenarios, whether the hole exists, the graph crosses the asymptote, that sort of stuff. So it just takes some practice looking at various different problems. Most of it's a repeat from 5-4, but then you got the holes and the intercepts and then whether it crosses the asymptote or not. Okay.